Hi, you are listening to Climatic Scale, a podcast about what it really takes to scale climate solutions. My name is Aneri Pradhan, host and co-founder of Climatic Group. Today, I am really excited to be joined with Peter Fankhauser, who is the CEO of ANYbotics. In a recent episode, we spoke with Siemens Energy about how they're deploying robotics to improve inspection and safety across their assets. Today, we're going behind the scenes with the company providing that technology, ANYbotics, to understand the solution, the applications across industries, and how they successfully landed and scaled with a major energy customer. Welcome, Peter.
Hi, Aneri. A great pleasure to be here today.
Thank you so much. So for our listeners, what is ANYbotics and what problem does your technology solve?
Yes, so at ANYbotics, we bring the power of robotics into the heavy industries, which is a lot also in the energies, but also heavy manufacturing, chemicals, and these type of environments. And what we do is step number one, we automate routine inspections. So we help the human workforce to build a safer work environment by taking over some of the tedious tasks. And imagine these facilities, they're constantly running. There's a lot of revenue to be generated. So uptime and reliability of these assets is of utmost importance. And what's needed to achieve that is data from the equipment itself. Now, there is data that the machines measure themselves, but there's so much data that still needs to be collected manually, environmentally, outside and in between the machines. I'll give examples later, but essentially what we're doing is automating that data collection. It allows to do more frequent data collection than manual. It's much more rich than what humans could do with high-end sensors. And that ultimately helps the human workforce to focus on what truly matters, and that is decision making, contextual understanding, and also removes the people from the tedious and often dangerous tasks exposed to hazardous environments. So for us, ultimately, it's using the power of robotics to build a human and robotic workforce that complements each other.
Thanks for sharing that. So you mentioned a little bit already about the data, which is, I think, super interesting. What types of data or insights are you helping operators capture that they couldn't before?
Yeah. Now, there's the concept and the working principle. Anything that you see deteriorating, a pump, a conveyor belt, a gas-fired power plant, these kind of things, anything it's almost too late. So yes, we do capture visual data with cameras, but I think really the power lies in collecting other types of data. And that's, for example, thermography. So measuring temperatures and not only measuring one temperature, but the entire image, right? Thermal images. That allows you to early on detect hotspots, be that overheating equipment, insulation that's failing, leakages, ball bearings that are failing, these kind of things that give you an early signal. Even earlier is acoustics. Imagine, right? We can sometimes sense that, hey, something sounds weird, but a machine can do that much more reliably and also in the ultrasonic frequency. So the vibrational footprint, especially of rotating equipment, allows you to intervene much, much earlier. So essentially, this type of data is collected by the robot. And imagine the robot has four legs, it's fully autonomous. It goes through these facilities very similar to a human, but it does that much more frequently and has all these high-end sensors on top. So for us, for the customers, it's a better way to collect data, but it's also better collected data. And then it's not only about collecting data, but understanding it. How did that deviate over time, the data, and what problems and anomalies can we find in the data to notify the reliability engineers that can assess and take actions on it?
That's really interesting. And where do you find customers typically see the biggest value first? Is it safety? Is it cost reduction, uptime, or something else?
Yeah, that's a great question. It's always a mix of these three things, actually. What you have an immediate impact in is certainly safety and cost reduction because now the robot takes over these routine inspection tasks. So it's man hours saved that can be spent elsewhere. And it's safety because you're removing people from danger zones. But the biggest lever certainly is uptime but that also takes the longest time to prove it ultimately. And there's two types of cases that we see. One is that it's a range of smaller wins, right? Hey, I found a smaller gas leakage over here. I was able to determine that a belt on a motor is deteriorating, these kind of things. These are often in the range between 5 to 30, 40,000 each a case that we can help. And it adds up over time. Every week, every month, you find something, it pays for the robot. The second type is these big black swan events, they call it. Things that are really disastrous that can end up in the millions in damages. Of course, you don't want them, but once you find one with the robot that, immediately pays, apologies, for the entire system. And it's also often a trigger point for customers. Hey, you've proven you saved us money here. We need more robots. It's now clear how to apply these systems.
That's really interesting. And how autonomous are the systems today? What level of integration is required on the customer side?
Yeah. So imagine the robot is fully autonomous. So the robot does the work by itself. It has a docking station to charge the battery, right? It gets up anytime you want it. You schedule it based essentially on a calendar multiple times a day. From some customers do it 3 times a day, some customers 40 times a day. And then it repeats the same task. It localizes it so it knows where it is. It sees obstacles in the environment, avoids those, and just collects the data. Right? So it does that. Now, the robot is all but not very smart. Ultimately, it's still a human that tells it what to do. So you program it or you prepare it through a mission, environment, checkpoints, and then the robot repeats it. But ultimately, it's hands-free autonomy. Once you set it up, you tested it, you just let it run and you forget about it and you're getting the data.
I think there's so many applications for what you described in the energy sector, which is where we'll move towards. So climatic scale focuses on scaling in the energy, mobility, and built environment sectors. So I would love to deep dive into how you work across these industries. So first, how are energy companies, and specifically clean energy companies, using your robots today, and which use cases are scaling fastest?
Yeah. So we are certainly in the energy or power and utility space in two areas. That's power generation and power distribution. Now, in power generation, including Siemens Energy, we work heavily and focused on gas-fired power plants where uptime is crucial and you have a lot of equipment. So very similar things that I mentioned before, reading out instrumentations, levers, oil gauges, making sure everything runs fine and also documenting what's happening. Second, overheating equipment, liquid leakages, and then, of course, gas leakages. So, gas concentration measurements. So, smelling something's in the air, but then also looking around and telling you, hey, where's that leakage coming from? And there's very exciting technology that we mount on the robot that can help you to do that.
Nice.
Second is power distribution. This is a lot in the utility substation space here in the US, for example. And there, the customer sends in the robot. They travel from site to site. They open essentially a van, open the fence, and let the robot in and let it do its job. And by now, there's dozens, hundreds of sites programmed, and the robot does a quick round. It takes him an hour. And what it scans for again is insulation through thermography and also partial discharge. So this is something as a human, it's very difficult to detect, but with high-end sensors, we can measure where's an insulation and bushings starting to deteriorate. If that continues, if the customers let it run, that can cause severe damages. But with a robot, we can find it earlier on and then trigger the maintenance teams to fix that problem earlier.
Yeah, that's really interesting. And actually just had a guest. I published the podcast this week actually with LanzaTech that manufactures biofuels and ethanol. So maybe that could be an interesting potential customer for you guys from what you just said. So what operational challenges are you seeing in the energy sector that make robotics particularly valuable?
Yeah. We see this across the industry. There is a need for highest uptime, reliability, performance. There's a pressure, right? Especially a lot of countries now in these days need to ensure energy production again. Sometimes we're not ready and there's aging infrastructure. So the need for information about the uptime is crucial. The problem is, and you could essentially solve it with a lot of people, but the availability of educated reliability engineers that can and want to do those types of jobs is rare. It's getting more and more difficult. all of our customers complain that they have people in their teams. There are more people above age 50 than younger. It's increasingly difficult to find the young people who can and want to do these types of jobs. And then the effect of that loss of workforce, it's not only availability of workforce, but it's also the knowledge drain. These people have been trained, they have spent decades on site, they know the signals of the facility, but it's very difficult to codify that, right? And hand it over. And so the trend now moves towards how do I now build that more systematically? How do I train the systems, the robots set up such that the new generation, they can actually focus on high level activities, as I mentioned, while the robots can take over some of these very tedious tasks that essentially nobody wants to do.
And I saw that ANYbotics is operating, have projects, I should say, all over the world and even in different kind of environments and high humidity or underwater. Which environments have proven easiest or hardest to deploy at scale?
Yeah, it's interesting. You would believe that the easiest environment would be the simplest. That is true, right? If you go in a very clean manufacturing facility, semiconductors, these kind of things, it's essentially easier from a standpoint of the robot for navigation mobility. But the effect is often harder to measure because it's already very sensorized often and often new facilities. So the biggest levers we have actually found in facilities that are aging and are quite harsh, as you mentioned, hot, for example, in the steel manufacturing, aluminum manufacturing, where it's dusty, it's almost exposed to the outside environment, hot, cold and hot temperatures fluctuating, high humidity across the countries. Other one is offshore anything, right? You have extremely high travel costs. It's exposed to the environment out in the ocean. So offshore wind is a big topic. What we found is wherever it's more difficult and more unpleasant for humans, the quicker the adoption of robots happens.
Ah, yeah, that makes a lot of sense. And also goes back to the safety point that you made earlier too. So when you start meeting a potential new customer or client, because this is a big investment, they would want to start with a pilot. So what patterns do you see in moving from a pilot to then a full deployment?
Yeah. At the center, and really we had to learn this the hard way, is not the robot. So we avoid speaking about robot as much as possible. Everybody, they in the beginning, they want to see the robot, they want to have it on site. We understand it. It's a cool robot, it's emotional as well, right? But it's crucial to take the customer on a full journey, be very consultative, understand what they're after, and have a deep, honest discussion about the problem you're solving. And then from our side, we have to consult, can the robot actually solve it reliably? Not only solve it one, but can it solve it 99.9% of the time? And then how much is that worth for the customer? So is this will it pay for the system? If not, how much? How many other facilities that are similar do they have? Is there scaling potential? So at the root cause, it's really down to what is the core problem you have or multiple ones, and is the robot suited to solve that? And this at the beginning, you can show it then through a pilot or even a demonstration. And after customers, once you have the discussion, they go, oh, actually, we don't even need a pilot because you have shown you've done it. Now we identified, we understood very clearly the problem. Let's go quickly. And we had customers going from 0 to 6, 10 robots immediately without going through that pilot phase. But of course, if a customer is very new to the topic and the problem might also not be 100% precisely scoped or it's unclear about the how reliably the robot can solve it, then you enter a pilot project. But then we very clearly specify KPIs and milestones that need to be reached in order to then trigger automatically an expansion of the fleet.
Oh, that's great. And just to go deeper on our case story of working with Siemens Energy, could you share how that relationship came about? Did they reach out to you? Did you reach out to them? Or if you don't know, what those maybe early relationship conversations looked like? Because that's what I find is this hardest part for startups is getting through the door.
Yeah. For us, actually, we had a luxury that we got quite easily through the door, I would say, because we're quite novel in the market. We have a quite visual product as a robot, so people immediately understand how this looks and feels like and gets them excited. There's also not a lot of robotics companies around in the world that do what we do. So we're quite unique. So in the case of Siemens Energy, that's so many years back, and Siemens Energy, AHA, and the team, early pioneers in the field, they found us in the beginning, also we published videos and then see what resonated. And then typically, I would say 95% of the requests were inbound. And for them was important that, hey, this is not only selling a robot to them and you'll figure out what to do with it, but we entered a long-term relationship and partnership. So they started small with a few pilots, with a few robots in the very beginning, a few years back, gave us very clear feedback on what was needed as well, which influenced the roadmap heavily. And on their side, they have the vision that they build up their software as well, right? And it needs to integrate together. So we started sketching out the vision. We had first trial implementations, then evolved from there. Ultimately, where they built the confidence, it's ready, and started to take this technology to their end customers. So moving out of the lab to on-site where they do the servicing at some of the facilities, including gas-fired power plants and offshore wind.
That's really interesting when you say that the expansion is actually through their customers. What were the metrics that led to them becoming your referral partner, not just your customer? And what do you think ultimately convinced them to choose ANYbotics for any of these types of projects?
Yeah. In terms of success metrics, is can you solve the problem? That's just the basics, right? Is the system reliable enough that it can do it? And is it clear that you have a joint go-to-market? So what is the Siemens Energy value for the customer? What is also that minimal implementation needs to be in place? Once those things are there, it's demonstrated, and in that case, Siemens Energy had the confidence, hey, it's working, then they feel courageous enough essentially to put their stamp of approval on it and provide it to their customers because then also their name and their credibility is on the line. Now, what I believe, what triggers these partnerships is the understanding that we're not just here to sell them a robot. As I mentioned before, this is a deeper partnership that evolves. We're taking feedback very seriously. We also don't have 1,000 customers and don't sell them each one robot. For us, we rather have a few dozen, a few hundred customers, but each of them can take 10, 50, eventually 100 and multiple hundreds of robots. So we're very focused as well, very consistent across the industries in terms of the use cases that we solve. And that gave us the credibility that we're the right partner and not just here to have a legged robot, because that's a legged robot is fun and good, but that's only the vehicle to ultimately perform the task of avoiding downtime, increasing safety, and a lot goes on top of the moving platform itself.
Yeah, absolutely. And actually, one of the things that Jaydeep said that really stuck out for me was that it wasn't just that your technology was good, he felt like the relationship was good and the communication. And so I'm curious, when you were working with them or other clients, actually, do you adapt your product pricing support model to work with a larger industrial client?
Because we only work with large industrial clients, we can repeat the same thing. And I think that's very important, right? We're not drawn all over the place to do things differently, but we hone in on our core markets, on our core customers, the core sizes also, right, matters, and build a consistent go-to-market strategy, but then also a customer journey. Otherwise, as a small company, you would be all over the place and things become inconsistent. And I think what these customers feel is that we're not only there, as I mentioned, to sell them a robot, but we're interested in the entire customer journey, which then means we also care about robot, the uptime, the success of the partnership. And you ultimately need that. Technology changes quite quick, but you need that trust mutually that you're headed in the same direction, the vision is the same, and you're there for the long run. And that partnership obviously then evolves, morphs. We mature quite a bit every year. The company looks a bit different and evolves, and we're learning. But what I'm very happy about is our approach has resonated really well across the industries, across customers.
That's great. And when you look at your projects, especially the ones that, are maybe more risk averse and want to start with smaller pilots, what is there any key learnings or opportunities that you've noticed that startups can really learn from into taking it from a landing to expanding and scale?
Yeah. I think in an emerging market, right? This is a new market.
Mhm.
Customers, they have not bought robots before. They don't know yet how to use. There's no budget line item for a robot, this robotic system like this. So there's a lot of market education needed, but then there's also the understanding that we say we're not selling a product, but we're selling essentially a project. And what I mean by that is it's very consultative. Big part of the revenue is then also the services that we provide from installation, training, expansion. And so the product itself is always the same, but it's not that the customer already know how to use it. And it's truly that partnership. And then this is then where you engage differently and you set up different contracts. So instead of just doing one unit deals constantly, you set up a multi-year contract that has milestones, co-development projects along the way, and that you become part of your customer's roadmap. And this is where ultimately how you need to engage in this complex enterprise deals to go from a few units and pilots to ultimately scaling with these customers.
I really like that framing because a lot of the climate tech startups that are listening have first of a kind technologies that also have to do market education. And what I think my key takeaway from what you just said is you've invested a lot into your customer success team in creating these processes to create buy-in throughout your industrial client, but also set up for multi-year engagements with very clear KPIs and milestones on hitting them. So that sounds like a really good investment you made in building out ANYbotics.
Yeah, and it's a little bit counterintuitive in the beginning, right? You're a robotics company, so it's all about making the robots do the work, and that's true. But because it's so novel, you need a quite sizable and smart and educated customer success management team that truly understands the customers. We're hiring reliability engineers in our team because often what we found is even customers, in this case, not Siemens Energy, but others, they have a massive challenge to find educated people that have the expertise even to understand how to solve the problems. While they understand the problems, they don't know exactly how, and they're very happy to rely on us as experts to set up the reliability strategy. Now, the only difference is we're not only using humans, but we're also using robots. So that's the force multiplier. This is what makes us different compared to other companies that only do reliability services.
Yeah. So industrial clients aren't known for being very fast at procurement, and the sales cycles can be long. So how do you manage them as a growth company?
Yes, it could always be faster, and we found that from sometimes it can go really fast from a few months to sometimes it takes over a year to go from initial discussions to shipping the first units. Ultimately, it's the and you cannot artificially make it fast and create pressure. They have the time, etc. But it's more important to understand what is their cycle, so you can appropriately forecast. Don't end up in situations where you hope it went faster. So it's early on having a transparent discussion. Who will need to decide? What are triggering events? How long is the budget around? When will it be around? Who's the decision making? All of that, and create a timeline together in the beginning that you mutually then go along with it. If there's any changes, it's okay, but it's about the proactive communications. That allows us to forecast precisely, anticipate, because on our side, we need to produce the robot, have the staff ready, all of that. And it's all about the predictability and the forecasting that allows us to then manage the growth appropriately.
Hmm. And so, what are your priorities for the next 12 to 24 months?
What's really exciting, right? We have now a few hundred robots in the field collecting data, running for hours and hours every day. So we're collecting a lot of data. So just in the last few months, we collected over 500,000 of autonomous inspection points. It becomes really substantial and we're quite unique. We have here a pole position in the market. And for what we're doing now is using that data to build a proprietary, we call it the industrial AI engine. Because as I mentioned, nobody can look at that data and some of the basic models that are out there, they're powerful, but where we can take really the next step is train special models specialized in inspection anomaly detection, and then eventually recommendations as well. So this is really powerful. This is an area where we're fully leaning into and going beyond what I call the robot platform, which is a very important element of our solution, but ultimately the value lies in the software. The second is also making robots easier to use. In the beginning, I said robots are relatively dumb in the sense that the human still tells them what to do. But imagine in the future, these robots have seen hundreds and thousands of facilities, and they will know soon better, how to inspect these facilities. So imagine you open the box, the robot comes out, takes a tour, comes back, and tells you, look, these are the machines. This is the equipment that I have seen. I know how they typically fail. This is my recommended inspection routine. And then you have a dialogue with the robot. Very similar to ChatGPT. Instead of you telling it exactly what to do, you start having a dialogue. And this is very exciting, makes it much more intuitive and more powerful to build the same models on a physical robot.
Hmm. That's super exciting. And I can see the business case very clear for your customers on, especially on your roadmap, on all the money they can save actually by implementing your solution. I'm sorry I did not prep you for this question, but I'm sure you get it all the time. There is a fear about robotics taking jobs, and I'm curious from what you just shared about like the robots doing inspections work, how you communicate about that, especially with policymakers.
Yeah. Yeah, it's interesting. That fear mostly is within the media and the public
Mm.
domain. When we talk to our customers, they always say, look, we don't find the people. And everybody knows this.
Mm.
They go as far that they say, hey, we're actually using the robot as a recruiting instrument. So they take it to high schools, to fairs. It's on their annual magazine. It's not only because they're proud, but it's positioning them as one of the thought leaders and technology leaders. And they want to attract the best people because they say, look,
Mm.
if you join us, you're not only a plant operator, but you're also a robot operator. So future proofing actually the positions that they offer, which is quite exciting. On other elements, we have always a big or involve in the discussion the unions as well, safety, cybersecurity, all of these elements. There's always some preoccupations, but once you tell them what the robot can do and what it cannot do, right? It's not going to take the hard decisions, etc. And how that collaboration can look like. The unions actually are very often some of the biggest fans of the robot because it's an investment into safety for their people, which is very important. And second, we had cases where the robot actually creates more work for the union, for the maintenance engineers, because instead of just running to failure and buying a new machine, you start fixing it, right? It's cheaper ultimately for the company to do, and it also creates, and it makes sense from the environmental perspective, and also it creates more work. So it's a win-win-win for everyone.
Yeah, no, I think that's makes total sense. It reminds me of in the 1960s, people were freaking out about computers taking people's jobs, and it ended up being the people who learned how to use computers were the ones that really that grew the workforce. And so it sounds like the same with robotics with young people in schools, learning how to manage robots, work with them, and that there's also career opportunities there. So
100%.
yeah. So Peter, if an energy or infrastructure company is listening, what's the best way to start working with you?
Reach out to us through the website, call us up, connect to me on LinkedIn. So all these possibilities are open, and let's have a discussion. We can talk about a robot, but what's much more important is to talk about what are the problems you have and where do we believe robotics can help. This is going to be very exciting discussion. There's going to be homework on the customer side to do as well. For example, we ask the customers to look at the last 2 years of downtime data or near misses in terms of safety incidents, these kind of topics. And then we hone in and really start creating a concrete case how a robotic inspection solution can help you get better. So reach out to us. We're very happy and we're, yeah, happy to engage, even if it's crazy ideas that we haven't thought of yet.
Oh, that's interesting. And if you could give a piece of advice to companies that, let's say, are maybe more traditional and haven't worked so much with new cutting edge solutions, and they're maybe starting to explore what
Mm.
they could be doing with innovation and robotics, what advice would you give to them?
Yeah, there's a couple of misconceptions that I hear. So, for example, because it's a robot, some of the customers feel like, look, we don't have robotics PhDs in our team. This
Hmm.
technology is too hard for us. I have some brilliant customers, and they tell me, look, we thought it's much more complex, but it's so simple to use because indeed, the robotics technology, it's all, we take care of that. The user interfaces, all of these things become very intuitive and easy to use. And people actually get quite motivated of using a new tool. The second aspect is what you mentioned. Are people going to fear that we're introducing new technology that potentially could threaten the work contracts and things like that? This is all often in the head of the management. Once you bring it on site and you have the people involved as well. So it shouldn't come just down as a top down decision. This is it, but involve the unions, involve the workers. All of them will see the benefit. And going through that change management process is also something we advise on. It can be done very positively and to great success, but it's also making sure that from the beginning you involve all the parties.
Yeah, no, that's great. I think that's great advice. Peter, thank you so much for your time. This conversation really shows that scaling climate and infrastructure innovation isn't just about new technology, but it's about proving value, building trust, and turning these pilots into long-term operational deployments through what you shared as a very strategic way to integrate yourself throughout the various business units. And thanks to our listeners for tuning into Climatic Scale. You can find our other episodes on climaticgroup.substack.com, our website, on Apple Podcasts, and Spotify. Thank you again, Peter.
Thanks so much for having me.